Hey everyone, in this video we are going to be talking about pipelining. So we'll start with an introduction to the concept of pipelining and then we'll take a look at some relevant exercises. So let's start first with an introduction to pipelining. Pipelining is a technique of decomposing a sequential process into sub-operations, with each sub-process being executed in a special dedicated segment that operates concurrently with all other segments. Now let's try to take a look at this with the help of an example. Say we want to perform combined multiplication and addition with a stream of numbers. So we want to perform an operation something like this. For each I between 1 and 7, we first want to perform multiplication AI into BI and then add that product into CI. Now each sub operation in this entire process can be implemented in a segment within a pipeline, right? Because each of these are individual operations. So what we can do is we can build a pipeline where each segment, each subpart of the pipeline is responsible for undertaking one subtask of this entire task, right? Each segment will have one or two registers and a combinational circuit, and this is what it will look like. If we had to perform this operation, a product and an addition, without using a pipeline, so the normal method of operation would be, first we take I is equal to 1, put I is equal to 1 in all of these. So what we're doing is A1 into B1 plus C1, and then we'll do that for I is equal to 2. We'll do A2 into B2 plus C2, and so on up to I is equal to 7. So what we'll do is essentially repeat this entire operation 7 times for each value of I. But when we use a pipeline, the whole point is to do this simultaneously. So how does this happen? See, in this process, there are two main sub-processes. First, we are supposed to form a product, and then we're supposed to perform addition, right? So first we take the product. AI and BI, both these values for all values of I will reside in these two registers, R1 and R2. R1 and R2 are now holding our first two variables, AI and BI. Then, since we need to multiply them, we'll put a multiplier. This multiplier will take as input whatever is in the register R1 and whatever is in the register R2 and produce a value. That value must also be stored somewhere, so we'll pick another register, right? Then, on the other end, we have a third variable. This also needs to go somewhere, so we have another register for it. Now, the product of AI and BI for each value of I will be stored in R3. The third variables will be stored in R4. For these two registers now, we can have an adder. It will add the contents of R3 and R4 and finally produce a value. The final answer for this equation for each value of I will then be stored in register R5. And you can see that this is a 3-segment pipeline. The first segment contains 2 registers. The second segment again contains 2 registers depending on the question. And third segment contains the final register. This holds the final answer. And this is what a pipeline is. So a pipeline, very basically, it consists of multiple segments. Segments have registers, one or more registers depending on the problem. And within 2 segments, we can have a combinational circuit. And in this case, our combinational circuits are the multiplier and the adder, right? This is very basically what a pipeline is. And the biggest advantage, which we'll also discuss later on, but from this you can see that the biggest advantage is that we can perform tasks that require repetition very easily using pipeline. So this is something that required repetition. So instead of doing this 7 times, what we have done is we have constructed this circuit, and this circuit will then perform this task, which was supposed to be performed 7 times. It will do it simultaneously. All right. Let's go into a bit more detail now how it actually works. See, R1 to R5 are the registers that receive the new data with every clock pulse. Again, remember, since we're talking about registers, their entire operation, the moving in of the data, the moving out of the data, is controlled by clock pulses. All right. Multiplier and adder are the combinational circuits. We have already gone through this. The sub-operations are important now. What sub-operations are being performed in each of the 3 segments of this pipeline? First, you can see A1 and AI and BI for each value of I from 1 to 7 go into R1 and R2. R1 and R2 are then multiplied using this multiplier. The result is stored in R3, and at the same time you can see in this segment R4 is also receiving whatever input it was supposed to receive. And finally, the contents of R3 are added with the contents of R4, so we can execute the equation AI into BI plus CI. So these are the sub operations that are performed in each of the segments of this specific pipeline. We can also try to understand it using this type of table. So these are the contents of the register at each clock pulse. Now we're going to see what happens in this entire pipeline with each clock pulse. So with the passing of the first clock pulse, when the first clock pulse arises, we have segment 1 here, which contains 2 registers, segment 2, which again contains 2 registers, segment 3 has only 1 register. So when the first clock pulse arises, the first 2 registers should get their respective inputs, and they're getting their respective inputs for I is equal to 1. Segment 2 and 3 are currently not doing anything at this moment. They haven't received any data. Then with the second clock pulse, segment 1 will now receive the next input, which is again A and B, but for I is equal to 2 this time, right? And the previous contents of segment 1 will now have moved to the next segment, segment 2, and you can see that A1 and B1 have moved into segment 2 after being multiplied, because there's a multiplier between segment 1 and segment 2. R4 is also receiving C1 at the same time in this segment, right? Segment 3 again is not doing anything at the moment because it hasn't received the necessary data yet. And then clock pulse 3 comes. What happens then is the segment 1, R1 and R2 will then receive the next inputs in the line, which are A and B, but for I is equal to 3 this time. The previous inputs of registers R1 and R2, the previous contents of R1 and R2 will move on to the next segment after multiplication. This is what happens here. At the same time in segment 2, R4 is receiving the next input, which is C2. Now segment 3 has an input, which is whatever the contents of segment 2 were. After clock pulse 3 hits, whatever the contents of segment 2 were will have undergone whatever they were supposed to undergo. In this case, this is addition, and they will move on to the next segment. And then you can see that with each passing clock pulse, new inputs are coming into the top segment, previous contents of that segment move on to the next segment, and then again with the clock pulse this cycle repeats, and so on and so forth. In the end, when we have the final input and the final output corresponding to that input, that's where the process of the entire pipeline ends. And you see all the results will then can be directly obtained from the final register, which is your output register, R5. Alright, before moving on, at this point it's important to understand that this specific pipeline that we have designed, this can only perform one operation, and that is AI into BI plus CI. That is it, because this is specifically designed to perform that operation and that operation alone. So while pipelines have this clear advantage of being able to efficiently perform repetitive tasks, only the data value changes but the actual operation remains the same. They're very good. Pipelines are very good at performing those kinds of operations. But it's important to consider that since it's expensive to set up all of this, like you're setting up the registers and then you have the multiplier and the adder, and the sequence has to be this and this only. So it's important to understand that pipelines are mostly used in circumstances where you need to perform repetitive tasks, but only one task again and again. Only then they will be efficient. Because if you're going to perform different types of tasks only 2 or 3 times, then you have to build different kinds of pipelines for each of those tasks separately. And after spending all that money and all that effort and all that resources into designing different pipelines, you're only using that like 1 or 2 times. So you have to really weigh the pros and cons. The pros are, For repetitive tasks, pipelines are good, but the cons are that they are resource consuming. So you have to really decide whether or not the application at hand really deserves that kind of effort, that you should really actually design a pipeline for that. All right, so now let's take a look at some simple exercises related to the basic information that we have gathered so far about pipelines. All right, problem one. In certain scientific computations, it is necessary to perform the arithmetic operation like this: AI plus BI multiplied by CI into D plus DI with a stream of numbers. Specify a pipeline configuration to carry out this task. List the contents of all registers in the pipeline for I is equal to 1 through 6. So you can see that there's a single arithmetic operation that you need to perform, but you need to perform it repeatedly for different values of I. And the question is that you need to design a pipeline that would do this, and then you have to list the contents of the registers involved in the pipeline. So let's begin. From the beginning, you can see that we have 4 variables A, B, C, and D. So definitely you're going to need 4 registers. So let's just put all 4 registers for each of these inputs. These registers will receive these inputs, right? This is segment 1, very first stage of your pipeline. Then what we need to do is AI and BI need to be added, and CI and DI need to be added, which means you'll have to put 2 adders. So you put 2 adders, and then the result of these adders, it must be stored in a register. So you need 2 more registers now, R5 and R6. So this was your stage 1, this was your stage 2 or segment 2. Finally, these 2 sums need to be multiplied. So these 2 outputs from R5 and R6 need to be multiplied. You need to add a multiplier here. So we've put a multiplier here, and again the result of this multiplier should go somewhere, so you put a register here. So you can see it's very simple to build a pipeline based on a given arithmetic operation, and the operation itself was not that complicated here. So this is segment 1, this is segment 2, this is segment 3, and these are the combinational circuits in between these segments. All right, problem 2. Draw a space-time diagram for a 6-segment pipeline showing the time it takes to process 8 tasks. Drawing a space-time diagram is very simple. Here's what we need to do. First, we need information regarding the number of segments in a pipeline, and in this question it's given straightforward. Then we need to know the number of tasks this pipeline is going to be performing. In this case, the number of tasks is 8. And the point of drawing a space-time diagram is to figure out how many clock pulses or clock cycles will be required to complete these tasks in this sized pipeline. And this is how we do it. So this is a table that we draw. On one side we have the number of segments. We just put them down, 1, 2, 3, 4, 5, 6. And on this side we count the number of clock cycles or clock pulses, 1, 2, 3, 4, 5, and so on. And this final value is actually the number of clock cycles or clock pulses that will be required to process these many tasks in this pipeline. And then we start filling up entries in this table. So since we have 8 tasks, we can name them T1, T2, T3, T4, so on up to T8. Now when the first clock pulse occurs, segment 1 starts performing the first task, right? So when the first clock pulse occurs, segment 1 starts working on the first task. So segment 1 is the first segment in the sequence. When the second clock pulse hits, T1, which was previously in segment 1, now moves to the next segment in the chain, which is segment 2. Segment 1 is open now, it's free. So it takes as input whatever the next task in the line is. It takes T2, it starts working on T2. And then when the third clock pulse occurs, T1, which was earlier in segment 2, now moves to the next segment in line, which is segment 3. T2, which was earlier in segment 1, now moves to the next segment, segment 2. And segment 1 is once again open, so it starts working on whatever the next task is, which is T3. Then the fourth clock pulse occurs and the same thing happens. T1 moves one step forward, T2 moves one step forward, T3 moves one step forward, and new task is assigned to the topmost segment. And then you just have to keep filling these entries until the end, until the point that all the tasks have been processed through all the segments of the pipeline. Now you'll notice here that when the 8th clock pulse occurs, T8 enters the system. It has entered the system at the 8th clock pulse. Now T8, when the next clock pulse occurs, it will move on to the next segment, because now it has to pass through all the segments, right? It's in one, it has to pass through all the segments, and then it will be exited from the system. So when the 9th clock pulse occurs, T8 moves to the next segment, then the 10th clock pulse occurs and T8 moves to the next segment, so it keeps moving towards the exit. And finally, with the 13th clock pulse, T8 is in the final segment of the pipeline, which is segment 6, and that is the end of your cycle, right? So you can see that it took 13 clock pulses or 13 clock cycles to process 8 tasks through all 6 segments of your pipeline, and that is what you needed to find out. So now you'll see that in this case we have found out this value using this diagram. There's another way to do that. There's a direct formula, but we'll learn about that in the next video. So there are two ways of finding out the same information. This way works fine as long as your pipeline is not that big, number of segments aren't that many, and the number of tasks are also not that many. But if you had thousands or 10,000s of tasks and you had large pipelines, then you won't be able to draw these diagrams. In that case, the direct formulas are used. But again, we'll talk about them in the next video. Alright, so far, just a quick recap. In this video, we've talked about very basic description of pipelining, just an introduction of what pipelining is, why we do it, how we do it using examples, and we took a look at some simple exercises, a couple of exercises related to our basic knowledge that we have gathered so far about pipelines. Now in the next video, we are going to be talking in detail about the general considerations of pipelining and the advantages of pipelining. And again, we'll take a look at some exercises pertaining to these topics.